Following data pertain to a single stage impulse steam turbine. Here the nozzle angle is equal to 20 degrees, blade velocity is equal to 200 meter per second, relative steam velocity at entry level is 350 meter per second, blade inlet angle is equal to 30 degrees, blade exit angle is equal to 25 degrees. If blade friction is neglected, the work done per kg of steam is. So here coming to the solution, first consider the velocity triangles for the given problem. So let us say this is the C1, that is steam velocity at the exit of the nozzle, and let us say this is CR1, this is relative velocity for the blade and steam velocity, that is the difference between these two represents blade velocity. And now draw again, one is from here, that is the velocity of the steam at the exit, and here the relative velocity at the exit. So CR2 let us say, and this is C or C0 and CR0. Okay, this is the given velocity triangle for the given problem, and here this represents blade inlet angle, that is 30 degrees, and here it represents blade exit angle, that is equal to 25 degrees, and here it is nozzle angle, that is 20 degrees. Okay, this is the given problem. Now the tangential components are given by, so here this is the tangential component for the inlet velocity, and this is the tangential component for outlet velocity CW2, and this is the blade velocity. So and the total tangential component equals CW equals CW1 plus CW2, and work done per kg of steam is given by, CW1 plus CW0 into C blade by 1000 in terms of kilojoules, where mass flow rate is 1 kg. So here we'll have to find out CW1 and CW0 first. So here we know that here we will have to find out CW1 and CW0, as we know that blade velocity. So here blade velocity is equal to 200 meter per second, and here CW1 from the diagram you can see that blade velocity plus CR1 cos 30. So which gives a value of 503 meter per second. So this is the tangential component of the velocity at the inlet, and here tangential component of the velocity at the outlet is given by CR0 cos 25. But here we'll have to know the CR0, but in the conditions the blade friction is neglected. So if the blade friction is neglected, here CR0 is equal to CR1, that is relative velocity at the exit is equal to relative velocity at the inlet. So that is equal to, here CR1 is equal to 350 and into cos 25. Cos 25. Sorry, here CR0 cos 25 gives the total velocity of C blade plus CW2. That is, we'll have to consider another term, that is minus C blade. So here the blade velocity is 200. So which gives a value of 118 meter per second, that is CW0 or CW2, whatever it may be. So here 118. Now the work done is equal 503 into 118 into, sorry, here 503 plus 118 into blade velocity is 200 by 1000, so which gives a value of nearly equal to 124 kilojoules. So in the option, the right option is A. A is the right answer. In a Morse test for a 2-cylinder 2-stroke spark ignition engine, it is found that the brake power was 9 kilowatts, whereas the brake powers of individual cylinders with spark cutoff were 4.25 kilowatts and 3.75 kilowatts respectively. The mechanical efficiency of the engine is. Generally, a Morse test is used to find out the friction power of an engine. So actually in Morse test, first we find the brake powers of individual cylinders are while spark cutoff for each cylinder. So here there are only two cylinders. While spark cutoff each cylinder, the brake powers of the engine are given as 4.25 kilowatts and 3.75 kilowatts. But the total brake power of the engine is equal to 9 kilowatts. Now, if you subtract BP1 from the BP, which gives 9 minus 4.25, which is equal to 4.75 kilowatts, which gives indicated power of first engine. And now, if you subtract BP2 from the BP, then which gives 9 minus 3.75, which is equal to 5.25 kilowatts, which is equal to indicated power of the second engine. Now the total indicated power is equal to IP1 plus IP2 and is equal to 5.25 plus 4.75, that is 9 kilowatts. Sorry, that is 10 kilowatts. Now we can find out the friction power, that is indicated power minus brake power, which is equal to 10 minus 9 and is equal to 1 kilowatts. Now, but here we will have to find out the mechanical efficiency. Mechanical efficiency is equal to brake power by indicated power, which is equal to 9 by 10, and the mechanical efficiency of the engine is 90%. 0.9, which is equal to 90%. So in the option, the right option is A. A is the right answer. The coefficient of performance of a refrigerator working on a reverse Carnot cycle is 4. The ratio of the highest absolute temperature to the lowest absolute temperature is, here COP of refrigerator when it is working on reverse Carnot cycle is given by T2 by T1 minus T2, where T2 is the lowest temperature and T1 is the highest temperature. So here we will have to find out the ratio of highest temperature to lowest temperature. But we know that the COP of the refrigerator is given by 4. So just take inverse of this equation, that is T1 minus T2 by T2 is equal to 1 by 4, which gives here T1 by T2 minus 1 is equal to 1 by 4, and T1 by T2 is T1 by T2 is equal to 1.25. So in the option, the right option is B. B is the right answer.